All right, so we're going to continue looking at the elimination method for solving a system of equations. But for now, we're going to be looking at a new method where we have to use elimination, but in this case, we have to change either one or both of our equations before we can eliminate the variables. And we're going to do that using multiplication. All right, so our standards, we're covering REI 5 and 6, solving system of equations approximately and exactly. So before we used elimination, and with addition and subtraction we solved a system of equations for x and y. Now what we're going to do is solve a system of equations by using elimination with multiplication first. And we'll also look at a couple of word problems. So when solving a system of equations using elimination, if the equations don't contain coefficients that will allow you to eliminate them by addition and subtraction, we have the ability to multiply one or both equations by a constant. And that'll give us two equations that contain the opposite terms. So we're allowed to manipulate and change one of the equations or both of the equations in order to cancel out coefficients with the opposite terms. Then once we've created these new equations, we're going to use the same process as we did on the elimination method before. We'll combine the two equations using addition or subtraction and solve for one variable. Then we'll substitute that variable into one of the original equations to solve for the second one, and then we will write our solution as an ordered pair. So if we take a look at this example, you'll be able to see what I mean. So it says use elimination to solve the system of equations. Well, if I look at this system, 2x plus y equals 23 and 3x plus 2y equals 37. Looking at this, right away I see that I can't really use elimination because for my x terms, 2x and 3x wouldn't allow me to eliminate them. They're not the opposite, they're not the same. Y and 2y, same thing, they're not the same. So how can I use elimination if my coefficients don't allow me to add or subtract these equations together to eliminate the variable? Well, what we're allowed to do is we're allowed to change the equations and eliminate, change the coefficients in order to eliminate the variable. So looking at these two equations, 2x and 3x, and 1y and 2y. Think back to when you had to find common denominators in order to add or subtract fractions. That's what we're doing here. We're looking for how to change either x or y so that they're the same number. So we're looking for a common coefficient between them. So what I see, the easiest one that I would do is to take this first equation here, 2x plus y equals 23. And if I multiply 1y times 2, it'll give me 2y. So I can rewrite these equations. My bottom equation here, 3x plus 2y, is going to stay the same. 3x plus 2y is equal to 37. That's going to stay the same. But what I'm going to do is I'm going to multiply my top equation, 2x plus y equals 23. I'm going to multiply everything there by 2. So it's similar to when you use the distributive property. We're going to multiply 2 times 2x. We're going to multiply 2 times y, and we're going to multiply 2 times 23. So if I do 2 times 2x, that's 4x. If I do 2 times 1y, that's 2y. And 2 times 23 would get me 46. So all we did was we took that first equation, and by multiplying by 2, notice I haven't changed the equation necessarily. I've just doubled it. 2 plus y equals 23. If I just double each of those terms, it becomes 4x plus 2y equals 46. So now, thinking back to what we did in the last lesson, what we can do is, since I have 2y and 2y here, I can subtract these two equations from each other. So I'm going to subtract each of these equations from each other. And what do I get when I do that? Well, if I take 4x and I subtract 3x, 4x minus 3x is 1x. And when I do 2y minus 2y, that's going to make this plus 2y. Think of that as a negative. So 2y minus 2y is going to be 0. And then I do 46 minus 37, and that gives me 9. So by combining these two equations, I've got 1x plus 0 equals 9, so x has a value of 9. And notice all we had to do was change the coefficient for y so that it was the same. That allows us to eliminate it. Once I know x is 9, I can choose either equation to substitute x back in to figure out what y is going to be. So take the original equation, 2x plus y equals 23. So 2x plus y equals 23. Well, now I know x is 9, so I'm going to change 2 times x to 2 times 9 plus y is equal to 23. And when I multiply 2 times 9, that gives me 18 plus y equals 23. And then I solve for y by subtracting 18 from both sides of my equation. So take the 18 away from the left-hand side, and if I take it away from the left, I have to take it away from the right also. And 23 minus 18 gives me a value for y of 5. So my solution to this system is x is 9 and y is 5. So I'm going to write that as an ordered pair. So 9 and 5. So that is my solution for this system. And I solved that by using elimination after I changed the first equation by multiplying it by 2. Okay, so now go ahead and pause the video and try to solve this system using elimination. X plus 7y equals 12 and 3x minus 5y equals 10. All right, so you should have gotten a solution of 5, 1. X is 5 and y is 1. So how would we get that? Well, looking at this system, x plus 7y equals 12 and 3x minus 5y equals 10, I see that if I want to eliminate one of the variables, I need to change one equation so that the coefficients are going to be the same. And the easiest way to do that is to take this first equation, x plus 7y equals 12, and multiply it by 3. So if I multiply each of these terms, x plus 7y equals 12 by 3, that gives me 3x plus 21y is equal to 36. My second equation is going to stay the same. It's going to remain 3x minus 5y is equal to 10. So now once I see that both of my equations, the x terms in each one have a value of 3, have a coefficient of 3, I'm going to subtract the second equation from the first one. Okay. And remember, what subtraction does is it makes each term the opposite. So we're doing 3x minus 3x, 21y minus 5y, negative 5y, which would actually make that positive, and then 36 minus 10. So by doing the subtraction, 3x minus 3x is 0. 21y minus negative 5y is actually positive, so 21 plus 5 is 26. y. And that's equal to 36 minus 10, which is 26. So 0 plus 26y is just 26y. And that's still equal to 26. So how do I solve for y? I divide both sides by 26. So take 26y and divide by 26. Take 26 and divide by 26. And 26 divided by 26 is 1. So y is equal to 1 for this system. So my y value is 1. So now how do I figure out what x is? I go back to my original equations. So we can take x plus 7y is equal to 12. And now I know y is equal to 1. So I'm going to change this to x plus 7 times 1 is equal to 12. 7 times 1 is just 7. And then to solve for x then, since I'm adding 7 on the left, I'm going to take it away. So I take away the 7 here, take away the 7 here, which leaves me with x is equal to 12 minus 7, or 5. So x is 5. Which gives me a solution to my system of 5 and 1, which was B. All right, what happens if we're left with a system where we have to change both equations? So if you look at this example, we've got 4x plus 3y equals 8 and 3x minus 5y equals negative 23. So if I want to solve for x and y, first off, using elimination, I can't just combine these using addition or subtraction because the coefficients of x and y are not the same. So then I want to use elimination. I need to change these coefficients by multiplying either the first equation or the second equation by a factor and changing those coefficients. Well, I can't change 4 directly into 3. I can't change 3 into 4. I can't change 3 to 5 or 5 to 3. So I have to think of what common multiples there are for either 3 and 4 or 3 and 5. All right, so looking at, let's take the x values. We're going to eliminate the x values first. All right, so 3x and 4x, what could I change those to in order to eliminate them? Well, I know 3 and 4 have a common multiple of 12. So if I could change 3x and 4x both to 12x, that would allow me to have the same coefficient in both equations. So what do I need to multiply 4x by to get to 12? Well, I'm going to multiply it by 3. And what do I need to multiply 3x by to get to 12? I'm going to multiply it by 4. So in this case, we need to multiply each equation by some value in order to change it. So 3 times 4x is 12x. 3 times 3y is 9y. And that's equal to 8 times 3, which is 24. So by multiplying that first equation, 4x plus 3y equals 8 by 3, it gives me 12x plus 9y equals 24. My second equation, 3x minus 5y equals negative 23, I'm multiplying by 4. So 3x times 4 gives me 12x. 4 times negative 5y is negative 20y. And that's equal to negative 23 times 4, which is negative 92. So now what have we got? Well, what ended up happening when I changed both of these equations, now my x term in both equations has a coefficient of 12. 12x here and 12x here. So that allows me to eliminate these using subtraction. I'm going to take away the second equation from the first one. So if I do 12x plus 9y equals 24 minus 12x minus 20y equals negative 92, what do I get? Well, 12x minus 12x is 0. If I do 9y minus negative 20y, that would be the same as adding. So I'm actually going to get 9y plus 20y, so that gives me a total of 29y. And 24 minus negative 92 makes this like addition. So 24 plus 92 is 116. So my equation is 29y is equal to 116. So now I solve for y by dividing both sides by 29. And 116 divided by 29 gives me a y value of 4. So by eliminating x, I found that y is equal to 4. So now I use that to go back and figure out what x should be. So take one of the equations. We'll just take the first one, 4x plus 3y is equal to 8. And now I know that y is 4. So it's 4x plus 3 times 4 is equal to 8. 3 times 4 is 12. So 4x plus 12 is equal to 8. Now I need to solve for x. So I'm going to take away the 12 from here, because my goal is to make it x equal, just x equals. Try that again. So take away 12 from both sides. So on the left-hand side we have 4x, and 8 minus 12 is negative 4. Solve for x by dividing both sides by 4. Which gives me a value of x of negative 1. So my solution for that system is that x is negative 1 and y is positive 4. Alright, so it's time for you to try. Go ahead and pause the video and see if you can solve this system using elimination. You should have gotten a solution of x is 4 and y is negative 1. So looking at this system, 3x plus 2y equals 10 and 2x plus 5y equals 3, we could choose either x or y to cancel out the variables at the beginning. Right? But either one I choose is going to require me to multiply each equation by a number in order to create coefficients that are the same. So for this first equation, let's say we're going to eliminate y in this case. So 2y and 5y, I can change each of those. They have a common multiple of 10. So how do I change 2y into 10y? By multiplying this first equation by 5. So 5 times 3x is 15x. 5 times 2y is 10y. And that's equal to 5 times 10, which is 50. The second equation, if I want to change 5y into 10y, I need to multiply this second equation by 2. So 2x times 2 is 4x. 2 times 5y is 10y. And 2 times 3 is 6. So now I've got two equations and they both have coefficients for y of 10. So in order to eliminate the y's, I'm going to subtract the second equation from the first one. So I'm going to take 15x plus 10y equals 50, and I'm going to subtract 4x plus 10y equals 6. So what do I get after I subtract all of those terms? So 15x minus 4x is 11x's. 10y minus 10y, again that makes that negative, so that's 0. So I eliminated y. And 50 minus 6 is 44. So I've got 11x is equal to 44. So now I solve for x by dividing both sides by 11. So 11x divided by 11 is equal to 44 divided by 11. So x is equal to 4 here. So my x value for this system is 4. So now I can go back to either one of my original equations and figure out what y is based on x. So let's take 3x plus 2y is equal to 10. So now I know x is 4. So 3 times 4 plus 2y is equal to 10. So 3 times 4 I know is 12, plus 2y equals 10. Now I need to solve for y, so I'm going to take the 12 away from the left side, which means I need to take it away from the right side also. So 2y is equal to 10 minus 12, which is negative 2. And now I solve for y. I'm going to divide both sides by 2. And when I divide both sides by 2, I get a value of y is equal to negative 1. So y is negative 1, which gives me a solution. X is 4, y is negative 1, which the correct answer was C. All right, so those are a couple of quick examples on how to use multiplication before we can eliminate the variables in a system of equations. So you can use elimination even if the coefficients don't originally contain either the same number or opposite numbers. You just multiply the entire equation by some factor in order to create coefficients that will allow you to cancel out and use elimination. Once you've solved for one of the variables, you replace it back into one of the equations to get the second variable, which will give you your solution to the system.